Greetings. My name is Chastity Selma Jhingree, and today's topic is the distance formula. The type of problems that we will be encountered is by given two coordinates, let's say 2, 4 and 6, 5, and we want to find the distance. What is the distance? We're given a Cartesian coordinate plane that has x-axis and y-axis. The x-axis is horizontal, left to right, and the y-axis is vertical, up and down. Coordinates are points that are written of the form x, y. The Cartesian coordinate plane is divided into 4 quadrants. In the upper right-hand corner is quadrant 1, x, y. In the upper left-hand corner is quadrant 2, negative x, y. In the lower left-hand corner is quadrant 3, negative x, negative y. In the lower right-hand corner is quadrant 4, x, negative y. When plotting points x, y, x before the comma is the x-coordinate, and y after the comma is the y-coordinate. We begin with the x-coordinate that is read from the x-axis. Then from the x-axis, we go up or down based on the value of the y-coordinate. For example, 2, 4 and 6, 5. To distinguish the two coordinates, 2, 4 would be x1, y1. We begin at 2 and we go up 4. 1, 2, 3, 4, which is this point. And for 6, 5 would be x2, y2. We begin at 6 and we go up 5. 1, 2, 3, 4, 5, which is this point. These 2 points would now be connected by a line segment. This line segment would be the distance. From the line segment, we create a right triangle. When having a right triangle, the Pythagorean theorem should come to mind. It states that a squared plus b squared equals c squared, where a and b are the legs. A is respect to the x-axis, x2 minus x1, which is 6 minus 2, that equals 4. And b is respect to the y-axis, y2 minus y1, which is 5 minus 4, that equals 1. C is the hypotenuse to the diagonal side, which will be the distance. So given this information, we're going to substitute into the Pythagorean theorem, a squared plus b squared equals c squared, where a is 4 and b is 1, which we then have 4 squared plus 1 squared equals 16 plus 1. 16 plus 1 is 17, c squared is 17. We square root both sides, which we then have c equals the square root of 17. By the law of roots, we have nth root of x to the m equals x to the m over n. So in our case, we have square root of c squared, which is c to the 2 over 2. 2 over 2 is 1, c to the 1. c to the 1 equals c. Therefore, the square root of c squared is c. So the distance of these 2 points is square root of 17. Now we're going to look at the general case, where these 2 points would now be x1, y1 and x2, y2. A is x2 minus x1, b is y2 minus y1, and c is d. We're going to substitute this information to the Pythagorean theorem, a squared plus b squared equals c squared, which we now have x2 minus x1 squared plus y2 minus y1 squared equals d squared. We're now going to rearrange it to have d squared equals x2 minus x1 squared plus y2 minus y1 squared. Similar to the previous example, we're going to square root both sides, which we then have d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Hence, we have our distance formula. We will now apply the distance formula to the given problem. Find the distance of given 2 points, 2, 4 and 6, 5. 2, 4 would be x1, y1, and 6, 5 would be x2, y2. x1 is 2, y1 is 4, x2 is 6, y2 is 5. We can substitute this information into the distance formula, which we have d equals the square root of 6 minus 2 squared plus 5 minus 4 squared, which now is the square root of 4 squared plus 1 squared, that is the square root of 16 plus 1, which then equals the square root of 17. The distance is the square root of 17. We have the same value in the case of utilizing the concept of the Pythagorean theorem. Examples using rational numbers. Rational numbers are simply fractions. Fractions that has a numerator and denominator. Numerator is the top part of the fraction, and the denominator is the bottom part of the fraction. Find the distance of given 2 points, 1/2, 3/4, and 2 1/4, 1 2/3. 1/2, 3/4 would be x1, y1, and 2 1/4, 1 2/3 would be x2, y2. x1 is 1/2, y1 is 3/4, x2 is 2 1/4, y2 is 1 2/3. Mixed fraction and improper fraction. Mixed fraction is of the form a, b over c. Improper fraction from the mixed fraction is c times a plus b all over c. The second coordinate has mixed fraction, which we will now rewrite it into improper fraction. So for 2 over 1/4, 1 2/3 would now be for 2 1/4, we will have 4 times 2 is 8, 8 plus 1 is 9, 9/4. And for 1 2/3, we have 3 times 1 is 3, 3 plus 2 is 5, 5/3. So this coordinate would now be 9/4, 5/3. We will substitute this information into the distance formula, which we have the square root of 9/4 minus 1/2 squared plus 5/3 minus 3/4 squared. We are subtracting fractions. When adding and subtracting fractions, we're required to have a common denominator. So in a general case, a over b plus or minus c over d, for a over b we'll multiply the top and bottom by d. For c over d we'll multiply the top and bottom by b, which we have AD over BD plus or minus BC over BD. Our common denominator is BD, which equals AD plus or minus BC all over BD. In another case, we have A over BD plus or minus C over D. In the denominator, they both have D, but the other fraction does not have a B. So for C over D, we'll multiply the top and bottom by B, which then has A over BD plus or minus BC over BD. So we have a common denominator. So this will now equals A plus or minus BC over BD. So for the first parentheses, 9/4 minus 1/2 squared, 4 is divisible by 2. 2 divides 4. So for 1/2, we'll multiply the top and bottom by 2. In the second parentheses, 5/3 minus 3/4 squared. Unfortunately, neither the denominator is divisible by one another, so we'll have to, for 5/3, multiply the top and bottom by 4, and for 3/4, we'll multiply the top and bottom by 3. Which we then have this, will now be simplified to the square root of 9/4 minus 2/4 squared plus 20 over 12 minus 9 over 12 squared. In the first parenthesis, you have a common denominator of 4. In the second parenthesis, you have a common denominator of 12. We just simply subtract the numerator, which then simplifies to the square root of 7/4 squared plus 11/12 squared. By the law of exponent, a over b to the n equals a to the n over b to the n. So we're going to rewrite these fractions into the square root of 7 squared over 4 squared plus 11 squared over 12 squared, which then simplifies to the square root of 49 over 16 plus 121 over 144. 144 is divisible by 16. 16 divides 144, which equals 9. So you multiply the top and bottom of the fraction of 49 over 16 by 9, which we then have the square root of 49 times 9 over 16 times 9 plus 144 over 121 over 144, which then simplifies to the square root of 423 over 144 plus 121 over 144, which we now have a common denominator of 144, so we simply add the numerator, which simplifies to the square root of 544 over 144. Again, by the law of roots, we now have the nth root of a over b to the m would equal the nth root of a to the m over nth root of b to the m. In our case, we have the square root of 544 over 144, which then expands to the square root of 544 over 144 over the square root of 144. And let's see if we can expand this even further into products, which it does, into the square root of 16 times 34 over the square root of 12 times 12. By another law of roots, we have the nth root of ab to the m equals the nth root of a to the m times b to the m, which also equals the nth root of a to the m times the nth root of b to the m. So in our case, we will expand this even much further to have the square root of 16 times the square root of 34 over the square root of 12 squared, which then simplifies to 4 square root of 34 over 12. 412 could be simplified to 1/3, which we have 1 square root of 34 over 3, which finally is the square root of 34 over 3. So the distance of the two given points is square root of 34 over 3. Thank you for listening.